when we go to do solving exponentials, how do we know it's solving exponentials? It'll say solve or determine a solution for it. But the key thing is that we have to have a variable and an exponent, correct? And the only way we can bring a variable and an exponent down is by either making common base or logging it somehow. So what we need to know is you'll convert to a log with one variable exponent. So you convert to a log with one variable exponent. That's one option. Or what we're going to also learn today is to log base 10 both sides. With 2 or more. So if we end up with 2 or more variable exponents, we're going to have to log base 10. We can't convert. Because we can only convert to a log if we have 3 pieces of information. Then the base becomes the base, what's with it doesn't stay with it, and then it equals the opposite when we do our conversions. Now, if we have 2 or more exponents, we could common base, if that's a possibility, right? But if it's not a possibility, we have to log base 10. Log base 10 always works. Common base only works if you can make a common base, but it's often faster. So look for common base first. So I go here, I have one exponent in my, or one variable exponent. Okay, so I still ask, can I make common base? That's what I should always ask when I have any type of variable exponent. No, I can't. So I can't make them both be base 2 or base 4 or anything. So now I say I have one variable exponent, so I should be able to convert this to a log, right? If I have 2 variable exponents, I'm going to have to log base 10, which is what we're learning today. So I have one variable exponent I can convert to a log. I have 3 pieces of information, so I can convert to a log. If I have more than 3, I'm going to have to move stuff around until I only have 3 pieces of information. Yes? Like we did with word problems. We would divide the initial over to the final. So I'm going to convert. So I go log base 4 because the base of my exponent becomes the base of my log. Correct? What's with it doesn't stay friends and when we do the conversion. So what's going to be beside my log now at the same height as the log? 12, and it's going to equal x. And if I wanted in exact values, I'm done. This is exact values. If I want it to the nearest hundredth, type it in, every single person, because you're practicing to type it in, because a lot of the time people can do the math and their typing it in skills are terrible because they just let Mrs. Lepp do it. And I don't do it on your test. So if I said round to the nearest hundredth, then that would be your answer. Exact values is not a rounded decimal. That's actually the complete opposite. Okay, it would be an antonym, we could say, to exact values would be give me a rounded decimal. Because that's not exact, that's a rounded decimal. Exact means every single thing, every single answer is there. Now, if it was an actual terminating decimal, like 1.25, that is an exact value, because 1.25 would be the same as its fraction equivalent, correct? Because it actually terminates. So a terminating decimal is an exact value, but anything but a terminating decimal is not. The moment you round, it's not a decimal. It's not an exact value. I mean, it is a decimal. All right. The next one has one variable exponent, so I can convert it to a log, but I can only have 3 pieces of information in order to convert. Currently, I have 1, 2, 3, 4 pieces of information. Good catch. So, what do I have to do first? Can I multiply this in with an exponent? No, did I tell you that's going to be the common error you're going to attempt to do? Yes. What do we have to do? Can't convert it to a log. Divide the 9.2 over, because this is like a word problem. This is like having the final and the initial. We always divide that initial over, right? This is like having the word problem set up for you and you're solving it. So we're going to divide that initial over, that 19.2. Now we don't use a rounded decimal throughout the question or we're going to be in trouble. So I'm going to leave it as 11 over 19.2. And now I'm going to convert, right? So I'll rewrite it just so it's not as messy looking. 11 over 19.2 equals 0.91 to the t. All right. Now do I have 3 pieces of information? Yes. Now I can convert. So I go log base what? 0.91, because the base of my exponent becomes the base of my log. What's friends doesn't stay friends. So what's it going to get beside it? 11 over 19.2, and it's going to equal t. Now this is the answer to the exact value. I want you to plug it into your calculator to get the answer to the nearest hundredth. Now, when I give rounding rules, remember, 100 has 2 zeros, so it's 2 decimal places. 1,000th has 3 zeros, 3 decimal places. 10th has 1 zero, 1 decimal place. So when they give you the word, it's literally equal to the number of zeros in that number. So if it's 10th, that's 1 0, 1 decimal place. 100th, 2 zeros, 2 decimal places. 1,000th, 3 zeros, 3 decimal places. Okay? Okay, so when we type it in, I just typed it in now.
5.91.
Yeah. So this is to the nearest hundredth, right? Hundredth. Not an exact value. So it depends on what I want. You do C. So I see one variable exponent, yes?
Yes.
If I have one variable exponent, I know I can convert it to a log if I have 3 pieces of information. Currently I have 4. And I can visualize this as a word problem. And then final, initial, this is increasing by 40% and they're looking for the number of years. Like this to me looks like a word problem, right? Like this is 1 plus 0.4, so it's increasing 40%. I have an initial value of 150, I have a final value of 300. They're asking for the number of years. Technically, I see that as a word problem. So they're asking it to double. So I have 150. So I get 2 equals 1.4 to the x. And then I can convert. Log, the base of my exponent becomes the base of my log, so I get 1.4. Beside it is 2, and it equals x. That's my exact value. What is it to the nearest hundredth? Anyone know? 2 decimal places? Pardon? 2.06. I got the 2 and they're like, blah, blah, blah. That's all I heard. Okay. Flip to the very back of your notes package where there's a blank page. For pre-doing something.
I was worth it ahead.
So if we get this, x equals log base 10 of 4 minus log base 10 of 2 over log base 10 of 3 plus log base 10 of 5. Say we get that as an answer, which we're going to get something like this as an answer when we have to do the next log step. Flip to the very back of your booklet. You're doing it on the blank piece of paper on the very back of your booklet.
Oh,
Got 2 of you. I had most of you. Now we got the last 2. All right. So I'm just making up a question, right? This will be what your answer is going to look like in the next step we're doing. Okay? We have to learn how to write this as a single logarithm. So how can we go about this? Well, we can do the top separately and the bottom separately. So the top is all both log base 10s, correct? And if they're the same log base 10 and they have a 1 in front, I can put them together. And then the denominator is log base 10. If they have 1s in front, I can put them together. Correct? We learned that yesterday. This is nothing crazy. So I'm going to get on the top log base 10, 4 over 2, because this has a plus 1 in front. This has a minus 1 in front. So I'm going to get 4 over 2. So technically on the top, I'm going to get log base 10 of 2. We agree? Nothing crazy there. Is everyone following what I'm doing? Okay, on the bottom, we now have a plus 1 and a plus 1, which we need, and we have a base 10 and a base 10. So we're going to get log base 10 of what? 3 times 5 which is going, because they're going to both go in the numerator because they have plus ones in front. So I get log base 10 of 15. Now, people with older calculators are actually going to find this easier because you do this every single time. So on your formula sheet, there's this last formula for logs. It has log b base b of c equals log a c over log ab. So they have this, log base b of c equals log base a of c over log base b of, or a of b. It's formula on my formula sheet, correct? Nothing, it's on my formula sheet. It's on your formula sheet, etc. So instead of it being base a right now, what are my bases? 10. Right? This is a base 10 and this is a base 10. Does it appear anywhere when I rewrite it as a single log? No. Those are going to go away. Because it would technically be log c over log 10, log b over log c over log a, log b over log a, and the log a's would cancel off when you multiply. I'll show you what I mean. So, everyone paying attention, put your pencils down. If I have log a of c and log a of b, you're not writing this, I'm just going to explain why the a's go away. If you have old calculators, you actually have to input it like this. Log c divided by log a, correct? And log b divided by log a. Is that true? Yeah? When you divide by something, what happens? You flip and multiply, correct? So these are just going to cancel off, aren't they? And I'm going to be left with log c over log b. Which, if you have the old calculators, you know that's the same as log base what? B of c. So if you have the old calculators, you're actually at an advantage on this because you know that this is how you actually have to go from here to here, right? So, if I have this, log base 10 of 2, log base 10 of 15, those 10s are just going to cancel off when I go to write my single log. And what's in the bottom is going to become the base, the b. Do you see that? The b and the b here? And the c and the c here. So I'm going to get log base 15 of 2. So that's this big, long, convoluted log into a nice little log. Do you want to see something cool? Type that into your calculator and get a decimal. Doesn't matter. Just type in, get a decimal, and let it sit in your screen. So everyone will have that sitting in their screen. Everyone's got an answer?
Yep.
Now if I do this, watch. So I have log base 15 of 2. Or I could actually write this as this. Log base, now this is 15 over 1, we agree? So I can flip it. I can make it 1 over 15 as long as I flip the other one. So this is 2 over 1, what's it going to be? 1 over 2, type that one in.
Some people want to. No way.
I was setting you up. I already told you they're the same. So they're going to be the same. Okay? They're going to end up being the same. And we need to know that because your answer might be log base 5 of 2, and the multiple choice answer might be log 1 over 15 and a half. Right? They're the same thing. You just end up flipping them. And you'll see why when we actually do mathematics in the next page, why that happens. So I'm going to give you another one, and I'm going to get you to convert it to a single log. We're going to practice another one. So x equals log base 10 of 4 minus log base 10 of 3 all over log base 10 of 6 plus log base 10 of 2. And then we're going to do one a little bit harder, and then we're going to actually go do the math of the questions we're learning today. So we're going to get x equals log base 10 of 4 over 3, because plus and a minus makes it numerator and denominator. And then we get log base 10 of 6 times 2 which gets us log base 10 of 4/3 over log base 10 of 12. So the answer would be log base 12 of 4/3. What could be my other option? Or log base 1 over 12 and then 3/4. Okay, our last extension. What if I do this to you? X equals 2 log base 10 of 3 minus 3 log base 10 of 2 over log base 10 of 4 minus 2 log base 10 of 3. Can I put logs together if they don't have plus or minus ones in front? No. How did we resolve that issue yesterday? The power rule. We brought it up and made it join that number. So you have one little extra step. Take that 2, make this be 3 squared. Take the 3, make this be 2 cubed. Take the 2, make this be 3 squared. And then you're exactly where I was when I gave you the last question. Right? So try that out. So we're going to get x equals log base 10 of 3 squared, which is 9, minus log base 10 of 2 cubed, which is 8, because the 3 is going to come up here, the 2 is going to come up here, over log base 10 of 4 minus log base 10 of 9, because the 2 is going to come up here. And so we're going to get log base 10 of 9 over 8 divided by log base 10 of 4 over 9. And then I'm going to get log of 4 over 9 for my base, 9 over 8 for what's beside my log, or log 9 over 4, 8 over 9. So once you've done that, go back to whence we came from.
This is easy. You give me the test now. I'm gonna go.
This is what we need to finish the next thing. That's going to have like 8 steps. I believe in you. No, you're going to do well. I said I believe in you. I wasn't joking. We're right here. This is for the people who live in step zone. Rinse, repeat. This will be a great day for you. But I still say to you that if you're memorizing steps, you can miss a step, correct? So it's better to understand why you're doing the steps so that you can just keep flowing. Because when you get a little bit of stress, memorizing steps is a problem. Because you get stressed and then you get stuck and you're like, I don't remember what I have to do next. So if we understand why we're doing the steps, you'll be in a much better position. All right. So we have 2 variable exponents. We agree? So I cannot convert it to a log. I can't. So what we do when this happens is we actually log base 10 both sides. Now we could just log both sides, which is log base 10, and that's how I used to teach this. But then I found that you guys put the 5 in the base of the log and the 3 in the base of the log. And so I realized you guys need placeholders. So I no longer do that. It's been like 8 years since I've done that. So now I go log base 10. So remember, with any equation, as long as I do it to one side and do it to the other, I can do whatever I want. Like I can multiply by 2, and I haven't changed the equation. I can multiply by 3, divide by 2, add 2, and I still have equivalent sides, right? So what we have to do is we have to get that exponent to come down. The only way we can get exponents to come down is by logging. Converting it to a log or using a log in some way, or that exponent's never coming down, right? So when I have one exponent, I can convert it to a log, boom, 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 my exponent pops down. When I have 2 exponents, I have to log something. Because the only way I can get an exponent to come down, if I log something, is by using power rule. Because the moment I have a log, can I take an exponent and drop it in front? Right? We learned that yesterday. The moment I have a log of both sides, I have a log. If I have an exponent sitting somewhere, I can take that exponent and drop it in front. It's power rule. It's allowed to happen, but only if there's a log in there, right? So that's why we're log base 10 in both sides. We're not just doing that because Mrs. Lepp said it's the first step. We're doing that because if I take the log of both sides, there's a rule called the power rule that says if I have a log, I can take my exponent and I can bring it in front. If I have one in front, I can bring it up. That's what I can do with logs. It's a real thing. We showed it yesterday by how I expanded the 2 to the 5. So we're going to log base 10 both sides here. We're going to do log base 10 of 5 to the 3x and log base 10 of 3 to the 2x minus 1. So now do you see why we're log base 10ing it? The moment we have a log base 10, you're not trying to drop that 5 or that 3 in the base. And if you don't write the 10, 98% of you will take that 5 and that 3 and drop it in the base. And then you'll be stuck and you won't know how to do anything. Okay? So I write log base 10. I know it's annoying. You're writing 10 a whole bunch of times. It doesn't matter. It will stop you from, prevent you from making an oopsie. The first 2 years I didn't, and everyone oopsie. Okay? So now, why do we take the log base 10 of both sides? Because the step was that? No, we take the log base 10 of both sides so that we can do what? Drop that exponent in the front using power rule. That's why we do what we do. If you understand why you do something, you might not forget the steps, right? So we log base 10 so that we can take these exponents and now drop them in front. So we're going to get, and I always put them in brackets, whatever I'm dropping in front. So I get 3x log base 10 of 5. Now 3x times log base 10 of 5 is just 3x log base 10 of 5. We agree? There's nothing crazy I can do with that. But if my exponent is a binomial, which this one is, I'm going to get 2x minus 1 in brackets times log base 10 of 3. And what do you suppose I'm going to do here now? So my first step is to log base 10 so I can take the exponent and drop it in front. We agree? My next step is to put that exponent in front in brackets so I remember to distribute. I'm going to have to take the 2x and put it in with the log base 10 of 3 and the negative 1 and put it in as well. I don't have to here because this is one term. 3x times log base 10 of 5 is 3x times log base 10 of 5. I can't do anything. It's one term being multiplied by one term makes it one term, right? But if my exponent is a binomial, like that 2x minus 1, which means two terms, I have to remember to distribute. And that's why I put it in brackets. Because if you don't put the 2x minus 1 in brackets, I have found through many years of teaching this, that you will write 2x minus log base 10 of 3 and you will call it a day. The 2x will sit by itself and you'll think the negative 1 is joined into the log. It is not. We have to distribute through. So this side just stays because it's a monomial times a monomial. 3x log base 10 of 5. And this side, I'm going to distribute that 2x through. So I'm going to get 2x log base 10 of 3 minus 1 log base 10 of 3. My ultimate goal when it says solve is to what? I need x, or whatever the variable is, in this case it's x. X equals number box. Correct? That's my ultimate goal every single time. Check for extraneous roots, circle those babies, get them out of there, everything like that. That's solving, right? I'm going to be able to y1, y2 every single time and check it. That's the great thing about solving, right? I can always check my answers. I know if I'm right or I know if I'm wrong. Every single time, doesn't matter what unit it is, it doesn't matter what math course I'm in. So I'm trying to get an x by itself equals something, right? That's my ultimate goal. So that's why once I've done distributing, I'm trying to get the terms with x's together. So that's right here. Get terms with the variable on the same side. So I'm going to subtract this 2x one over. So I'm going to have 3x log base 10 of 5 minus 2x log base 10 of 3 equals negative log base 10 of 3. Why the heck would I get the x's together? Why would I get the terms of the x's on one side?
Cross them off when you divide them.
Can't cross them off. Watch this. So this is a 3 times an x times a log base 10 of 5, technically, is it not? Mm-hmm. And this is a 2 times an x times a log base 10 of 3, technically. There's no plus or minus signs in there. They're all multiplied. So what do they have in common? 3, 2? No. X, x, yeah. Log base 10 of 5, log base 10 of 3 is not common. So it's the only thing common to both of them. An x. And the reason why we pull them to one side is so we can GCF an x out of them. Both. Because it's all multiplied. So if I take an x out, I'm now left with what? 3 log base 10 of 5. Minus 2 log base 10 of 3. equals negative log base 10 of 3. It seems way more complicated than it is, guys. We are literally one step away from having the decimal answer, and then use what we just learned to get the exact value. My x is, some people get stuck here. They're like, I don't know what to do. How do I get an x by itself if this was just something sitting here? How would I move that over? Yeah, this is being multiplied, is it not? I don't know what of these is. There we go. It's being multiplied, so I just divide that whole kahuna over. So we could technically right now type it into our calculator. And this would be a rounded decimal. So I would make sure I use my fraction button if I have it. And do I need to put base 10? Or can I just press the log button?
Log for base 10.
No,
You can just press the log button, because the log button is base 10, right? So I can go negative, I can use the fraction button, and I can go negative log 3 over 3 log 5 minus 2 log 3. And I get negative 0.42 as my approximate answer, if they said to the nearest hundredth or whatever, right? Now, what if I want exact values? We go back to where we were in the previous, that last page, all those practices. So we have x equals negative log base 10 of 3 over 3 log base 10 of 5 minus 2 log base 10 of 3. How do I get these together? We just did this. It is a bit harder if you have this negative sitting out by itself. So what I do is I bring it up as a -1, because then it's positive and I just think it's easier for myself. I bring that negative sign up as the exponent because it's just a -1, right? And I just bring it up. It's a -1 sitting here and I just bring it up as an exponent. And then I bring the 3 up. And I don't bring the -2 up, I just bring the 2 up for this one. I'm going to get a 3 here and a 2 here. So I have x equals log base 10 of a third, because 3 to the -1 is a third, over log base 10 of 125 minus log base 10 of 9. Then I can put them together. I get log base 10 of a third over log base 10 of 125 over 9. And I rewrite that as log base 125 over 9 and a third. Or how else could they give it to me? So this is an exact value. Or how else could they give it to me? Or log base 9 over 125 with a 3. Or 3 over 1, which is the same thing. And you're going to flip it over. What's on the top of the next page? You try it.
Okay. Wait, are you trying to try one or
Try one. Not that one. Where did my page go in the middle? All right. So we log base 10 both sides so that we can drop the exponent in front. We drop the exponent in front so that we can distribute.
Yeah, that's what it is.
And so we get 2x log base 10 of 4 minus log base 10 of 4 equals x log base 10 of 3 plus 2 log base 10 of 3. And our goal is to get the x's on one side so we can GCF out an x, logs on the other side so we don't have to do that. So we get 2x log base 10 of 4 minus x log base 10 of 3 equals 2 log base 10 of 3 plus log base 10 of 4. So I just added the log base 10 of 4 to the right, and I subtracted the x log base 10 of 3 over so that I can take out an x, because they're all just multiplied. So I take out an x, and I'm left with 2 log base 10 of 4 minus log base 10 of 3 equals 2 log base 10 of 3 plus log base 10 of 4. And I'm going to divide that over so the x is by itself. So I get x equals 2 log base 10 of 3 plus log base 10 of 4. Will we know that we're right or wrong when we're done this? Yeah, we could always type our exact value or our decimal, our exact value in, and get a decimal. And then we can y1, y2, and see if the decimals match, right? We should always know if we're right or wrong whenever it's a solve. Even when you're done your exact value at the very end, you turn that into a decimal and see if it matches the decimal. Then you'll know if you messed up where you messed up. Because every single one of these steps, if I y1, y2 this one, y1, y2 this one, y1, y2, y1, y2, y1, y2, y1, y2, I should get that same answer every single step. They all are the same thing. So if you're ever like, ooh, where did Sam error? Well, let's check this one, same answer. Check this one, same answer. Check this step. Ooh, it's not the same answer. Sam errored in step 2. You know what I mean? Like you can literally check with your calculator too. So I could type this in and get a decimal, or I can get an exact value by moving the 2 up. Move, there's nothing up. Move the 2 up, nothing up. So now in the numerator, I get log base 10 of 9 times 4. And in the denominator, I get log base 10 of 16 divided by 3, which is log of 36 with the base of 16 over 3, or log 3 over 16, 1 over 36, which is weird, but we need to know that we get out of it. Okay, we have one last one that I want to get through. What happens when I have this extra 2? I have one extra step, and it's not to go 2 times 3 is 6. Remember, you cannot put a number in if the other number has an exponent, right? I'm not allowed to do that, right? So you stop yourself. If you do that, you immediately get a 0 on the question. Very easy to mark, very sad for me. I'd rather mark a harder question and get you full marks than get you a 0 because you put 2 times 3 is 6. So we do the same steps. We get log base 10 of 2, which is technically multiplied by 3x, equals log base 10 of 6x plus 1. And this is immediately, this next step is where I stop. I either can mark and keep going, or I know you're wrong. Because this is the only extra step when you have that extra number. There's one extra step, and then we're back to what we did on all the previous questions. When I have 2 logs and I'm multiplying something, how could I rewrite this? Log 10 2 plus log 10 3 to the x. There's your extra step. Separate them by addition. Remember 2 things that are multiplied? You deserve your hooray. That was really good of you. When you have 2 things multiplied, you can expand them into an addition. That's that extra step. That's it. That's all it's going to be. Remember the rule of product rule is I can take 2 multiplications and I can separate them out as 2 logs with addition sign. That's it. We're using the reverse of the rule. So log base 10 of 2 plus log base 10 of 3 to the x equals log base 10 of 6 to the x plus 1. And then I do all the exact same steps. I drop my exponent in front. Now I'm back to every single same step I had before. This one just goes along for the ride now. Log base 10 of 2 plus x log base 10 of 3 equals x plus 1 in brackets log base 10 of 6. I have to distribute my x plus 1. So I get log base 10 of 2 plus x log base 10 of 3 equals x log base 10 of 6 plus 1 log base 10 of 6. Then our same next step. What's the next step? Get our x's to one side, everything to the other. So I'm going to go x log base 10 of 3 minus x log base 10 of 6 equals log base 10 of 6 minus log base 10 of 2. So there's literally one extra step, just noticing that you have to add them. Take an x out, and I'm left with log base 10 of 3 minus log base 10 of 6 is log base 10 of 6 minus log base 10 of 2 divided over. There's literally one extra step if there's that extra number. Do not put them together. Stop your madness. It's the worst thing to mark. You get no marks. And to get our exact values, none of them actually have a number in front of them. So they're nice. So I get log base, bless you, 10 of 6 divided by 2. And then log base 10 of 3 divided by 6, which is log base 10 of 3 over log base 10 of a half. So my two answers in exact values could be log a half, base a half of 3, or what? I know it's box your answers, pretty proud of them. Your homework is 2 questions. The first question has 4 where they're just to convert to a log, real quick, like the first ones we did. And then the other one has 4 questions that are like these. People are like, practice them tonight. Do not push off your homework. Because if you practice these, you'll lock it in. Is it locked in right now? No, it's like there. You practice the questions, you'll lock it in. If you practice 4 questions, you'll be able to do this. So please do your homework tonight. It's page 413. I don't know what I'm writing. Page 413, number 2 and 7. So it's 8 questions total. The 2 has 4 parts. It's just converting to a log. There's one variable exponent. And then 7 has 4 questions. The first 3 are like the first we did, where it was just something to an exponent equals something to exponent. D is like we just did. It has that number with something to an exponent, something to an exponent. So D has that one little extra step, so watch yourself.